Boom. So today we get to move on to 221, and we're going to talk about how we can transform any graph. So we've been looking at our little quadratic, and we've been looking at our quadratic in usually like that vertex graphing form. And we went through, if we look at problem 76, and we were talking about ways we can transform that, right? Ways that we can move it. So we want to take our knowledge that we gained off of moving that quadratic and see if we can do the same thing of moving a function to the left, to the right, up, down, stretch it, compress it, and flip it. But we want to see if we can do that to some different types of functions. So if we can do it to like y equals x to the third or y equals 1 over x, and kind of all of those little fun things, right? So we're going to use Desmos, and we're going to put those into Desmos, and then we're just going to play around to sit there and see if we can get all of our graphs to move to the right, move to the left, move up, move down, stretch them, compress them, and flip them. So it's a little bit of a dance move going on today, right? So we need to talk about our parabolas, because we've been talking about parabolas. If I... Where are we at? Whoop. So when it came to our vertex form and it came to our parabolas, this was that vertex / graphing form, and we did some investigation on this to sit there and try and figure out how everything moves around, right? And so through our Desmos investigation that we did on this one, that A, if it was positive or negative, it depended on how it flipped, right? For us, we were doing a quadratic, so we had that parabola, that U shape, right? And if A was positive, it opened upward, so it kind of whoop. Right? And if it was negative, it flipped it over the x-axis, so it turned it upside down. And then we looked at A. If A was a number greater than 1, it took our graph and it stretched it, or it made it skinnier, right? Because we got there faster, so it made it skinnier. And if our A was between 0 and, well, just over 0 or up to 1, it sat there because we'd get there at like half the speed, so it took us longer to get there. So it kind of like compressed it, or it pushed it out, made it nice and fat. We found out with our H, that's what makes it go left or right, all right? And that was in with our X. And the way I kind of remember that is we know that x-axis, right, goes left and right. So since it's in the parentheses with that x, it's going to shift the x. So the part that's in the parentheses or with the x, that's what's going to move it left and right. And then our k is what makes it go up or down. And then whatever our exponent is, that's going to give us the overall shape, right? If our x was 1, we knew it was going to be a line. If it's a squared, it's going to give us a parabola. If it's to the third, it's called a cubic, so it kind of gives a little floopy floop in there. So let's play around with some Desmos, right? So when we look at our, they give us the equations they want us to look at, right? Y equals x to the third, y equals 1 over x, y equals the square root of x, y equals the absolute value of x, and then this y equals b to the x, which is exponential. And we're just going to put in there where like our b is 2. So I'm going to type in all of our equations. So we had what? Y equals x to the third, right? And then we had y equals 1 over x. The square root of x. And I'm just going to throw y equals out there in front because we like y equals. Y equals the absolute value of x. And y equals 2 raised to the x, the exponent. So your graph looks all nice and nasty up there, right, when it comes to Desmos. So on Desmos, if you want to not see a graph, but yet you want to keep it on there because you don't want to keep retyping it, all of the colors indicate like which graph it is. You can click on those and it saves it, but it takes it off of the graph. And then if you want it back on, you just click it and then you get it back. Isn't that cute? Make this a little bigger, right? All right. So we're going to start with y equals x to the third. Okay. So the first thing they want us to do is try to figure out how to take our graph and how to move it to the left or to the right. Anybody got any ideas what we could do with our y equals x to the third to make it go left or right? Right, good answer. Good job. Yep. So when it came to that x squared, the part that was with the x, like inside the x, that's what moved it left or right. So if we threw a parentheses around our x, do you want to go left or do you want to go right? Right, right. So if we want to go to the right, is it going to be a positive or a negative? A positive? Did that move it to the right? Yeah, when you're moving left and right, it's going to be the opposite, right? Because remember, the equation is x minus h. So I think we figured out how to move it left or right. Okay. What if we looked at the second one, that 1 over x? What do you think? So let's stick with going to the right maybe. How do you think you might move that one to the right? Where are we going to add it? Where do you think? In the denominator? Plus or minus? Want to try plus? Did it move it to the right? Or did it move it to the left? Yeah, so it should be x minus h. Yep, and it's going to move it to the right. Good job. What about a square root? What do you think we need to do? We know we got to subtract 3. Where do you think the minus 3's got to go? Like under the square root or on the outside of the square root? Yeah. Oops, I forgot to take that one off. Here, we'll go back. All right. Oh. Did it move it to the right? Yep. What about the absolute value? Where do you think we're going to put the minus 3? In the absolute or outside of the absolute? Right? No, in the absolute, right? Because we're going to keep that baby with x. Here's our exponential. Do you think we can move that one to the right? Wonder what happens if we put a minus. Whoops. Oh no, oh no, 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 no. Don't want all that. No coding for today. Did that one take the whole thing and shift it to the right? Yeah. So if we want to move it left or right, we got to make sure whatever family of function we're dealing with, it's got to be with the x, right? So think of x. X is that x or the going left and right on the axes. So if you want to move anything to the right or to the left, you got to put it with the x, right? Good job. So let's go back to our parent function on all of these. So we got the left and right, so now we need to go up and down. So if we go back to our graphing form, what part made it go up or down? The k, right? That k is kind of all alone, right? He's not with the x, he's all alone, right? So if we go back to our x plus 3, or x to the third, sorry. Trying to do two things at once. See, multitasking doesn't work very well. Do we want to go up or go down? Up, right? Keep going up, right? How many do we want to go up? Stick with the 3? Yeah. All right. So how do you think I'm going to move this guy up 3? Negative 3? Did that move it up or down? That one moved it down, yeah. So I bet you this has got to be a positive 3, right? Nice. What about our 1 over x? If we want to take that whole thing and shift it up 3, what do you think we're going to do? Plus 3 at the end? Look at that. Yeah. What about our little radical? Plus 3. Whoop. Did it move it up 3? Sure did. What about our absolute values? What are we going to do? Yep. On the outside plus 3. Look at this. Man, you guys got this all figured out, right? Then we got our little exponential growth. If we want to move it up 3, what are we going to do? Plus 3. And it moved it up 3, right? Very cool. Yep. So remember when I told you guys, like when it came to us working on these, when it was just the parabola, I'm like, make sure we kind of get these figured out because it's going to work the same regardless of what family of functions we're looking at. Flipping it over the axes, how do you think you're going to flip it? How am I going to get that baby to flip over? Put a negative out front. Yep. How am I going to get this one to flip over? I'm going to put a negative out front. Yeah. How am I going to get this one to flip over? Put a negative out front. How am I going to get an upside down V? Put a negative out front. Yeah. How am I going to flop that exponential? Put a negative out front. You guys are on fire. You guys got this. Aren't you so proud of yourself? All right, and then the last one is either compressing it or stretching it out, all right? So if we think of x to the 3rd, if we want to, do we want to make it skinny or make it fatter? Want to make it wider or skinny? We want to go wider. All right, so if we're going wider, that means we're compressing it, right? Because we're pushing it down to make it go out wider. So if we want to compress it, what do you think is going to go out front? A number less than, right, between 0 and 1. What's a good number between 0 and 1? 0.5, half, right? So just for easy, I'm just going to put it as a fraction, right? So we were here, and then, whoop, did I kind of spread it out a little bit? Yeah. If I want these guys to be spread out a little bit, give it 0.5. It's kind of hard to tell on those ones, but our radical, what are we going to put out front? 0.5, right? And we can see that it took longer for this because our normal one goes up here, right? So it's kind of pushing it down. We got our little V shape. We want our V to be a little bit more wider, so we're going to put a 0.5 up front, right? On our exponential, put a 0.5 out front. Because it did go through 1, right? Now it dropped it down, so it got there half as fast. So it kind of squishes it down. And if we wanted to stretch it and make it skinnier, what kind of numbers would we put out front? Greater than 1. Yep, yep. Awesome. So as long as we, especially like I say, like when it comes to the vertex or that graphing form, I mean, this one is for a quadratic, but it pretty much works the exact same way with no matter what family of functions, right? The number out front is either going to stretch it or compress it. If it's positive or negative, that's all going to the same way. The part that you put with the x is going to move it left or right. And the piece that's not with the X or in the parentheses with the X is going to make it go up or down.